we are going to, this, I don't know why, but this topic was not in the online book that we had for this class, and it needs to be, because what we're going to be doing as we go on in chapter 3 is we're going to be doing some factoring, and if you don't ever learn how to factor or remember how to factor, we're going to be in trouble. So I'm adding this one in. So I called it the supplemental section. I made a new section, so that's what we'll be doing tonight. If you really like looking at the book, I took some information from a different class and I stuck it in there. So there's like 3 sections that I attached to this. I picked up some more problems. There are tons of practice problems for you to look at. And then there are going to be 10 graded questions for you to actually do. Remember that section 3.1 is not due until a week from yesterday, so Monday the 8th, I guess. And then this one will also be due on that same day. So I did cover 3.1 last week, but I said it wasn't going to be due until next week, Monday. So just remember that. Make sure you're working on it. You may need to go back and watch the video or watch some of those videos that they have by the problems so that you can remember what we covered last week. But we're going to talk about factoring. And some of you may remember factoring from when you were in math classes previously, and some of you may not. So I wanted to make sure we reviewed it so everybody had a foundation in factoring. So factoring quadratics. Remember quadratics? The exponent is 2. The degree is 2. And that's what we're going to be working with here for this section. So what we have to remember is factors are just things that are multiplied together. So like you might have heard in the past when you were really young, the factors of 6. Well, the factors of 6, like 2 times 3 equals 6. So 2 and 3 are factors of 6. Or 1 times 6 is 6. So 1 and 6 are also factors of 6. And so factors are just things that are multiplied together to get a product. So when we look at some of these things here, and these look kind of complex, but we're going to start out with factoring out a greatest common factor. What is called a greatest common factor. So let's take a look at this one. And I don't do this all the time, but just initially on a couple of these examples, I'm going to show you how they get completely broken up. 3x squared actually means 3 times x, right? Does that make sense? That's what 3x squared means. The squared means you multiply it by itself, and it only applies to the x. Minus, and then 6, we just said factors of 6 are 2 and 3, right? So 6 is really 2 times 3, and then we also have that x. So the 3x squared is 3 times x, and then the 6 is 2 times 3 times x. So when we factor out a greatest common factor, what we're factoring out is anything that they have in common. That's the common part. So we want to factor out the greatest, the biggest thing that they have in common. So we can see they both have a 3, right? So we'll be able to factor out a 3 from both of those. They also both have 1x. Now this one has 2, but this one only has 1. So as far as what they have in common, they have 1x in common. So we can also factor out an x. So a 3 and an x. When we're doing this, we're dividing it out. So we divide out this 3, we divide out this x. What's left in that first term? Just 1x, right? Because we factored out the 3, we factored out the x. There's 1x left. And then we have the minus sign. And yeah, what's left here? Well, just the 2. So when we factor that out, that is factoring out a greatest common factor. We just find out what they all have in them, and we take out whatever's in common. Okay? So now this one is a little bigger. There's 3 terms this time, right? So let's see if we can do it without writing out all the factors like this. Let's think about it one piece at a time. Let's think about the numbers. 8, 6, and 2. What number could we divide out of each of those 8, 6, and 2?
2.
A 2, right? 2 divides evenly into each of those. So we're going to factor out a 2. Then we have x to the 4th power, x to the 3rd power, and x. So if you're thinking about the x's, how many x's do they each have that we're going to be able to factor out, that they have in common? Just 1x, right? So this one has 4 x's, this one has 3 x's, this one only has 1 x, so we can only factor out 1 because that's what they have in common. Does that make sense? Okay, so factor out 1x. Then let's think about the y's. We've got y squared, y cubed, and y to the 4th. How many y's, or what power of y, can we factor out of each? We've got 2, 3, and 4, right? No, it's a 2. So we can factor out y squared. All right, now here's where we have to be careful. We're dividing out, right? So we deal with the number 8. We divide out a 2. What's going to be left? A 4, right? So we're dividing out 8. We're dividing out a 2. If you have x to the 4th and you factor out one of those x's, how many x's are left? 3. So it would be x cubed. And then if we have y squared and we factor out y squared, there are no y's left, right? So then that's the first term. Then we put our plus sign down. And we do the same thing again. So 6, we're factoring out a 2. What's going to be left there? A 3, because we're dividing out the 2. We have x cubed, and we're factoring out an x. What's going to be left there? X squared. Huh? And then we have y cubed. We're going to factor out a y squared. What's going to be left there for the y's? Just 1 y. And so that's the end of that term. Then we put our minus sign down. We have a 2. We're factoring out a 2. What's going to be left there? Yeah, we've got the minus sign, but it's just going to be a 1, right? Okay. And then we have an x. We're factoring out an x. What's going to be left there? It's actually still a 1, but we've already got a 1, right? So we don't need to write it again. We've got y to the 4th. We're factoring out y squared. What's going to be left for the y's? Y squared, 2 of them. Because we had 4, we factored out 2 of them. So y squared. And that is how you factor out that greatest common factor of that one. I don't need to be in the picture, so we'll get out of the way. Okay. So does that kind of make sense for those first ones? We're going to be using this skill over and over again, so I think you'll be pretty good at it by the rest of the night. So the first thing we always want to do anytime we're factoring is we always want to look for a common factor first. Because if there's a common factor, it's going to make everything else smaller and easier to work with. Okay? And so you always want to look for a common factor first before you try to do anything that's a more complicated factoring method. Okay? And I'll just tell you, this particular supplemental section here is going to be a lot of examples. So you're going to see all sorts of different examples of factoring. Okay? Not tons of words, there are a few, but mostly examples. So are we good to go on? All right. So this one looks a little bit different, but we still have this idea of a greatest common factor. Now, here's the thing that's a little bit weird about this. Notice where the only, as far as the whole thing, this whole thing is multiplied together, right? So that's like one group. And this is multiplied together, so that's another group. What do you see that both groups have in common? The x minus 3, right? Because this is multiplied, so we have to take out factors. So they both have an x minus 3 in them. Does that make sense? Everybody see that? So we can factor out that x minus 3. Now, what's going to be left in this first big chunk when we factor out the x minus 3? Yeah, just this piece is left, right? 2x plus 4. And then we've got a minus sign. And what's going to be left in the second chunk when we factor out the x minus 3? Just the 5. Okay? Does that step make sense so far? We just look at what they have in common and factor out whatever they have in common. Now, here's the last thing we want to do. At this point, these parentheses aren't really doing anything. There's nothing multiplied by 2x plus 4 that these parentheses are necessary. So really, we can just get rid of these parentheses. And what does that allow us to do inside of this bracket here? just combine the like terms, the 4 and the -5. So we've already got the x minus 3 on the outside. And then what will we have on the inside? We'll have 2x minus 1. So we can even do a little bit of simplifying on that one once we do the factoring. Okay, so again, what we're always looking for to begin with is a common factor. Is there anything we can factor out of all the terms? Okay. So there we go. Now, oh, one other thing I should mention right here. Notice the order of factors. When you multiply, the order doesn't matter, right? Like 5 times 7 is the same as 7 times 5. The order doesn't matter. So when we see that over there, that's the same as this. So as long as the factors are correct, the order that you write the factors doesn't matter. Okay. So any questions on that one before we go on? All right, let's take a look at another one. Okay, so we have practiced factoring out a common factor. This is the other thing that we want to practice before we go on to a bunch of different stuff. It's called factoring by grouping. And factoring by grouping, we're going to be using a lot tonight. But factoring by grouping, you can only do when there's an even number of terms. Now, it doesn't always work when there's an even number of terms. But that's the only time we can even try it, is if there's an even number of terms. So what we do is we look at the first half and then the second half. And we ask ourselves, in the first half, the 12n cubed and the 4n squared, is there a common factor that we can take out of just those two terms? They both have a 4 in them, right? 4 divides into each of these. Okay. And this one has n cubed and this one has n squared, so we can take out an n squared from both of them. Now, what's left after we factor that out of this first group? What's left in the 12n cubed? There will be an n and also a 3, right? Because 12 divided by the 4 leaves you a 3. So you've got a 3 and you've got an n plus. Now, what happens with this one? When we take the 4n squared and we divide out a 4n squared, what's left there? A 1, because you're dividing, right? So 4n squared divided by 4n squared is just 1. Now, here's the thing with factoring by grouping. Whatever this sign is, we've got to factor it out. Okay, so if it was a plus, we just leave it as a plus. If it's a minus, we factor out a negative. Okay? Is there anything else that these have in common that we can factor out? 3n and 1? No. So we're just going to leave it as 3n plus 1. Now, notice what we've done. We have this first group still, and we have the second group. Looking at them as two groups now, do we see that each group has something in common? Yeah. They both have a 3n plus 1, right? Just like on that last example we did. So we can factor out the 3n plus 1. Now, what's going to be left in this first group when we factor out the 3n plus 1? Yeah, the 4n squared. Now, here's where we have to be careful. We've got our plus sign. What's going to be left here when we factor out the 3n plus 1? Because remember, we're dividing it out, so it's going to be a 1, right? 3n plus 1 divided by 3n plus 1 is 1. Anything divided by itself is 1. So we're going to have a 1 there. And so this is this thing factored out. Now, in the past, we've done multiplying, right? And we would distribute. If you take this and you multiply it back out, which we're not going to do right now, but if you multiply it back out, you should get right back to here. That's how you could check your answer if you wanted to. Okay, so what we're doing is we're kind of undistributing when we do this factoring process. Okay? So, and again, we're going to see this. We're going to be dealing with ones that are just squared. That's the highest power, but this one has a cube in it just so we can see the example of how we do factoring by grouping. But that's how we do factoring by grouping. Always an even number of terms. Always group the first half and then the second half and see what they have in common. We're going to do that. We're going to do that quite a few times. Okay? And again, the order that you write those factors in does not matter. Okay? So I think I'm going to skip this one. This is just the same type of thing, but I want to get to how we're going to apply it to our problems. So let's skip this one. But it turns out to be that if you really wanted to see it. Okay. So we're going to be dealing with quadratics. Quadratics are going to look like this: ax squared plus bx plus c. Okay. We are going to talk more and more about those, but we're going to talk about factoring quadratics. We're going to get into more about quadratics in our next section. Actually, you can forget this part. We're going to use the four-step method to factor. In my classes, when I teach in high school and I get to see everybody every day, we do a lot of different types of factoring. We're going to focus on one here so that we don't get anybody confused. We're just going to do one type all the time. Okay? So we're going to use a four-step method. You will want to write these down, and then I'll go through several examples of how we do them. But here's the 4 steps. First step, we're going to multiply the a value times the c value. So that means the number that's in front of the x squared times the number that's over here all by itself. Okay, we're going to multiply a times c. The next thing we're going to do is we're going to find factors of a times c. So a times c is just going to be a number. We're going to find the factors of a times c that will add up to equal this b value in the middle. And again, I'm going to show you lots of examples of this, so you're going to see that. So factors of the a times c, two things that multiply together to be a times c that will also add up to be b. Okay. Then here's what we're going to do. We're going to rewrite the expression. So it used to have 3 terms. We're going to rewrite it so it now has 4 terms. And what we're going to do is we're going to break up that middle term, the b times x. We're going to break that into 2 parts based on the numbers we found in part 2, step 2. And I'll put this up here and I'll give you some time to write. But the last thing we'll do is then we will factor by grouping, which is what we were kind of just doing, which is what we were just doing with those other problems. So those 4 steps, we're going to do those over and over again tonight. So you guys will get really good at this, hopefully. Well, good tonight, and then you'll practice it. You'll get even better. Okay, are we good to move on? It looks like people are done writing. Okay, so let's do an example here. We'll start out with some simple examples, and then we will slowly get them more complicated, but we want to start with some simple ones first. So first question that I have is, we're going to multiply a times c, but what is the a value here? It's a 1. There's nothing written in front of the x squared, so automatically it is a 1, correct? So we're going to multiply 1 times 12, a times c. 1 times 12. And obviously that is 12, right? So we've got 12. Now we're going to look for the factors of 12 that add up to be 7. Now we want to put on our thinking caps here a little bit. And we're going to look at 2 signs to help us figure this out. The first one we're going to look at is this one right here. I'm going to multiply 2 numbers together, and I'm going to get a positive 12. What do you know about those 2 numbers then? What do you know about the signs of those 2 numbers if you multiply them together and you get a positive answer? They could both be positive, but what's the other option? They could both be negative, right? They have to have the same sign. Does that make sense? Because if you multiply a positive times a negative, you get negative. So this plus sign right here tells us that these are either both positive or both negative. It's one of those 2, right? Then let me grab a different color. Then we look at this one. Because these 2 numbers that we're looking for are supposed to add up to be a positive 7. So if you add 2 numbers together and you get a positive answer and you know they have the same sign, and we make sure we're thinking. If I add two negatives together, what will the answer be? Negative, right? If you multiply them, you get a positive. But if you add a negative, like if you lose money and then you lose more money, you don't magically have money, right? You lost more money. So a negative plus a negative is a negative. A positive plus a positive is a positive, right? You gain money, you gain more money, you gain money, right? When you're adding, it works the way we would expect, right? A negative and a negative stays negative. A positive and a positive stays positive. So if we're adding these two numbers together and we get a positive and they're either both positive or both negative, this part right here tells us we're looking for two positives, right? Because they have to add up. They have the same sign. We already know that. And they have to add up to be a positive 7. So let's start writing down the factors of 12. Well, we know that 1 times 12 is obviously 12. But does it add up to be 7? No. We know that 2 divides into 12 6 times. Does those two add up to be 7? No, but we're much closer, right? We're at 8. 3 divides into 12 4 times. Does that add up to be 7? Yes. So that's what we do. We just start listing the factors until we find the ones that will multiply to be 12 and add up to be 7. Now here's the step that people get mixed up on sometimes, and we're going to do this over and over. We're going to rewrite. This is step 3. We're going to rewrite this original expression. Here's how we do it. We copy down the x squared, but the middle term right here, we break into plus 3x plus 4x using these two numbers right here. And then plus 12. Now, does everybody see that this is okay because isn't 3x plus 4x equal to 7x? We haven't changed it. We just broke it up in a convenient way.
Wouldn't it be x squared if it's 2 x's?
What do you mean?
Like
If you're adding?
Like how, yeah, because there's 3x and 4x, but there's only one 7x. So
Right.
what is there?
But they're added. So when you add, you combine like terms so you don't change the variables. If you were multiplying, then you get x squared. Does that make sense?
Yeah.
Okay. So here's what we do. Now we have how many terms? 4, right? We have an even number of terms, which is what we wanted so that we can do our last step, factoring by grouping. So we group the first two, and we group the second two. And what do we see that we can factor out of the first group? Just an x, right? Nothing else. What's left? X plus 3. Then we take this plus sign, and what can we factor out of the second group? Is everybody okay? There's a 4 there? So we're dividing out a 4. What's going to be left here? X plus 3. Now, if we did this correctly over here, we should always have a common factor to factor out. Okay? If we don't get a common factor, we did something wrong. All right, so what can we factor out now of the first half and the second half? The x plus 3. What's left when we factor out the x plus 3 right here? An x, and then you're right, a plus 4. And so that x plus 3 times x plus 4 is the factored form of that first piece. Okay? And that's the process. We're just going to do that process over and over again. Okay? So x plus 3 times x plus 4. Are we okay to go on to another one? All right? You're probably going to get sick of this because we're going to do it over and over again. But okay. So looking at this one, we start out the same way, right? A times C. What's A? 1. And what's C? -3. So we get -3. Now let's put on our thinking caps again. If I multiply two numbers together and I'm going to get a negative answer, what do I know about the signs of those two numbers? That makes sense? One's positive, one's negative. And we can see that, right? The 1 was positive and the -3 was negative. So these are going to have different signs. One's positive, one's negative. That's what this sign right here tells us. They have to have different signs because when you multiply them together, you get a negative answer. Okay? Then we still look at the middle. This time it tells us some different information though. When you add, and we may be digging down deep into our memory banks here. When we add numbers that have different signs, and we're not using a calculator, how do we add them when they have different signs? How do we determine if the answer should be positive or negative? The bigger number, you take the sign of the bigger number. So if I have a positive 7 and only a negative 2, when I add them together, the positive outweighs the negative, right? But if I have a negative 12 and a positive 10, there the answer is going to be negative because the negative one outweighs the positive one, right? So if I'm adding these two numbers together and I'm getting a negative answer, which one has to be the bigger one? The negative one. So I'm just going to circle this so that we remember, as we're writing these down, the bigger one is negative. Now 3 doesn't have many factors. In fact, it only has one pair of factors. 1 divides into 3 times. We know the bigger one has to be negative. Does that work? Does it add up to be negative 2 and multiply to be negative 3? Yeah. So then we go to step 3. Rewrite it. X squared plus 1x minus 3x minus 3. Again, it's okay because these two, we're just breaking up that middle term. Okay, because 1 plus negative 3 equals negative 2. So now we have our 4 terms, factor by grouping. What can we take out of the first group? You got an x squared and a 1x, so you can take out an x, right, or a 1x. What's left in that first group when we factor out the x? This will have an x, and this will have a 1. Okay. Now remember I mentioned we have to take out this sign, so we're going to have to take out a negative. What else can we factor out of both of these? A 3. They both have a 3 in them, right? So when we divide negative 3x squared, negative 3x by a negative 3, what do we get? Well, just the first part is 1x, right? When we divide negative 3 by negative 3, we get 1. Negative 3 divided by negative 3 is just 1, so plus 1. So again, notice what do they have in common? X plus 1. We factor that out. What's left in the first part? The x. What's left in the second part? Minus 3. So x minus 3 is our other factor. Okay? And we get our answer there. Well, you can't see it because it's behind my writing. That's our answer. And again, the order of the factors doesn't matter. Okay? I'm going to skip some of these because I put a lot of examples in here, and they're going to get a little repetitive. So let's go on to something that looks like this. So what's different about this one now? The difference is, what's the a value this time? It's 7. It's not a 1 this time. Okay? So we do the same work, though. Right? We're going to multiply. I may need some help with a calculator here. We're going to multiply 7 times negative 28. Can somebody help me out? What is 7 times negative 28?
Negative 196.
Negative 196? Okay, now again, we're putting on our thinking caps. What does this sign or this sign, they're going to be the same. But what does that sign tell us about the signs of the numbers we're looking for? I heard somebody say it. They're going to have, oh, I thought I heard something else. They're going to have opposite signs. One's positive, one's negative. Because you multiply them together, you get a negative answer. Does that make sense? So this tells us one's positive, one's negative. Then we look at this, and what does it tell us?
Bigger ones could be negative.
Bigger one's negative because it has to outweigh the positive one to make the answer negative. So the bigger one is going to be negative. All right. And let's start writing down the factors of 196. Now, 196 has a decent number of factors, right? But I just, like I said, you may know it right away, but otherwise you just start going through. I always start with 1. Well, how many times does 1 divide into 196? 196. And we know the bigger one's negative, but does that add up to 45? Nope. So we go to 2. 2 divides into 196. You can use a calculator, but it's going to be negative 98. Does that add up to be negative 45? Nope. Let's try 3. Does 3 divide evenly into 196? Those of you who have a calculator. It does not actually, right? Okay. So let's skip the 3. Let's go to 4. 4 will work. How many times does 4 go into 196? 40 what?
49.
Negative 49? Aha, there's the 1, right? A positive 4 and a negative 49 adds up to be negative 45. So if we just keep going, we'll find it eventually. If we don't, that's something totally different we'll talk about after a bit. Okay, so what are we going to do next? We want to come back here and rewrite it. So we'll say 7x squared plus 4x minus 49x minus 28. Again, these two. The whole point is that we're okay because they together equal that middle term. Then we have 4 terms we can factor by grouping. What can we take out of the first group? In this case, just an x. So what's going to be left when we divide out the x? 7x and plus 4. Okay. We have to take out the negative. What can we take out of both of those? Yeah, we've got the negative, but we're also going to be able to take out a 7, right? So we're going to divide out a negative 7. So negative 49 dividing out a negative 7 will give us 7, and then we still have the x. Negative 28 dividing out a negative 7, positive 4, which is really convenient because we know it should match up as long as we did our work correctly. So we can factor out a 7x plus 4 from both of those. What's left in the first half? Just the x, and then here, you're right, minus 7. So even if there's a number in the front, that's okay. We're going to do the same process. It's not going to make any difference. Okay? Does that make sense? Or at least hopefully starting to make sense as you see the pattern repeated over and over. Okay? Okay, what are we going to do right away here? You're going to get sick of me saying it, but it's a times c, right? What's the a value? And the c value? So 2 times negative 6 equals negative 12. Okay, time for our thinking caps. What does this being negative or this being negative tell us about the signs that we're looking for? They're opposite, they're different. So one's positive, one's negative. What does this sign tell us now?
Positive is bigger.
The positive one is the bigger one. So that's different. So far, the negative one's been the bigger one, I think, each time. But this time, the positive one is bigger. Now, it's not bigger by much because what is this supposed to add up to?
1.
A 1, right? There's a positive 1 in front of that. So let's look at factors of negative 12. And you may know the answer already, but negative 1 and positive 12, because the positive one's bigger this time. Does that add up to be 1? No. Negative 2 and 6? No. Negative 3 and 4? Yes, we have a winner, right? So what are we going to do next? Rewrite it. 2x squared, using these, minus 3x plus 4x minus 6. And then we group them. Oh, I need to pause here for a second. Some of you may wonder, how do I know if I should put the 4 first or the negative 3 first? It doesn't make a difference. The process won't change. You'll still get the same answer. So you don't have to worry about, oh, I put the wrong one first. It doesn't make any difference. Okay? So don't worry about that. Whichever one goes first. I just put them in the same order that I have them over here, but it doesn't make any difference. What can we take out of the first group? Just an x. What's left? 2x minus 3. What? We got to take out the plus sign, so plus. What can we take out of the second group? A 2. And what's going to be left there when we divide out that 2? 2x minus 3. And again, you guys are hopefully not just automatic, but I mean, we know it should be the same, right? So what can we take out of both of those now?
2x minus 3.
2x minus 3. And what is left?
X plus 2.
Correct. Okay. Is that making sense? All right. Now, I haven't been saying it, but really, what did I say right away at the beginning? We should always be looking for a common factor for all 3 of these. Do these have all 3 a common factor?
No.
No, but we should always look for that because it's going to make things smaller and easier to work with. All right, let's look at this one, and then I think we're doing okay here. We may jump ahead a little bit. So looking at this one, we start out the same way, right? A times C. So 2 times 20, which is 40. And this is positive. We notice that's positive. So what does it tell us that this is a positive? When we multiply 2 numbers together and we get a positive answer, what are the 2 choices? They're the same. Either they're both positive or they're both negative. So our options are, I should have circled this with blue, but this is telling us, or this is telling us, they're either both positive or both negative. Okay? And in this case, we look right here then, and it tells us, somebody said it, they're both negative. Right? Because they have to add up to be a negative. And when you add up 2 positives, you don't get a negative. All right, so factors of 40 that are both negative this time. So -1 and -40 doesn't add up to -13. -2 and -20 doesn't add up to -13. Let's see, 3 doesn't go in there evenly. You can check it with a calculator, but it doesn't. 4 divides into 40 how many times? 10. We're really close now, right? That's -14, but not -13. 5 divides into 40 how many times? 8. So, all right, we got it. That's the one. -5 and -8 is -13. So what do? We rewrite it, right? So 2x squared minus 5x minus 8x plus 20. We want to group them. What can we take out of the first group? An x, and that's it. That's kind of boring, but I've had that a lot of times, right? What's left? Okay, and then remember we have to take out the negative. What else can we take out of those 2 terms? 4 divides into both of them evenly, right? So we're dividing out a -4. What's going to be left here? 2x. What's going to be left here when we divide by a -4? -5, right? They have to match up as long as we did our work correctly. So what can we factor out of both of those? 2x minus 5. And what's going to be left? The x minus 4. So are we getting that pattern? Okay? Okay. I don't want to bore you to death because it's the same pattern over and over and over again. It's just we have to think about, are they both positive? Are they both negative? Or do we have one of each? Okay, so that's why you always want to think about what does that last sign tell us? Tells us that they're the same or different. And then the middle sign tells us if they're the same, if they're both positive or negative. If they're different, it tells us which one is the bigger one. Okay? All right, we're going to skip this one. I do want to talk about one type. I'm going to show you a couple, but I'm going to focus on one type of special pattern. You actually could do it with what we've been doing, but it gets a little bit tricky. So one type of special pattern that we have is when you only have 2 terms instead of 3, and they're both perfect squares. Okay, so for instance, you might have an x squared and a 9. So both of those are perfect squares, x times x, 3 times 3. Or you might have something else, and they have to be subtracted. It's called the difference of squares. Okay, now the other couple of patterns that I'm going to show you, I wouldn't waste time memorizing this. This one we're going to want to know right here. We're going to want to know that one, how it factors. It's always first part plus second part, first part minus second part. These two, not as important because just do what we've been doing for the last 10, 15 minutes. You just do it the same way, and you'll just find out that if you factor this, it will turn out that both factors are the same. Same thing happens here. Both factors will be the same. But you don't have to do anything different unless you really want to memorize the pattern, which you could. We were talking about Mr. Jansen. He was very good at memorizing the pattern. I never was. I didn't memorize this pattern. I would just do the factoring, and then it just popped up. Okay? So here is an example of that first type, the difference of squares. And the way I suggest to do it is, does everybody recognize pretty quickly that 9 is a perfect square? And do we recognize pretty quickly that 16 is a perfect square because it's 4 times 4? So I would write this as, okay, what squared gives us 9x squared? The number part is a 3, and then it's an x, right? 3x times 3x is 9x squared. What squared gives us the 16? 4. So once you've identified this, we can follow the pattern. So here's the pattern. A squared minus b squared factors to be a plus b times a minus b. If that's not in your notes, you probably want to write that one down. Okay? And a just stands for the first parentheses, and b just stands for the second parentheses. So if we're going to follow this pattern, the answer will be first parentheses, 3x, plus b, second parentheses, so plus 4. And then over here we have first parentheses, 3x again, and minus the second parentheses, which is a 4. So once you've identified the first part and the second part that are squared, it's just 3x plus 4, 3x minus 4, and that's it. Now, actually, you could do that process we were just doing, but when you get that a times c, they have to add up to be 0 in the middle, which means they have to be the same, but opposite numbers. I mean, different signs, but same value because neither one is bigger, and it makes it a little confusing sometimes. So that's why this is the one pattern that would be probably worth learning. Okay, and like I said, on the practice section of your My Open Math, there's lots of practice problems. You don't have to do them all, but I put a whole bunch there, so you can, as much practice as you want, you can get tons of practice. Okay, so 3x minus 4, and again, the order that you write them in does not matter. All right. How about this one? This one only has 2 terms again, right? But is 12 a perfect square?
No.
Is 75 a perfect square? No. But do they have a greatest common factor that we can factor out? And the answer is yes, they do. Does anybody know what goes into 12 and 75?
The 3.
It is a 3. Okay, and you might have to do some work on a calculator to get that. But 3 goes into both of these. So if we factor out a 3, we have 4m squared minus, what's 75 divided by 3? Think quarters. 25. Right? 3/4 is 25, or 3/4 is 75 cents. Okay. Now, do these look like perfect squares? Right? So I'm going to write it, and I'm going to say, okay, what squared gives me that first piece? 2m, right? 2 times 2 is 4, and we've got to have the m. Minus, what squared gives us 25? 5. So we've still got the 3 out here, but what are how is this going to factor then? 2m plus 5 and 2m minus 5. Like I said, once you identify these two, it's just put a plus in between them, put a minus in between them, and then you're done. There's a bunch like that on the homework, on the practice and homework too. So you'll get some time to look at that. Okay, so factor out the greatest common factor first if there is one. Okay, now these last two, I think these are the last 2 examples. The last 2 examples, there's one thing that's different about them. I think we've talked about this before, so it may not be completely new. But what do you notice that's different about these that was not on any of the others?
Equals 0.
Equals 0. These are now equations that we want to solve. but we start out doing the same thing. We're going to factor them. So what do we do first? Well, greatest common factor. Is there one?
No.
No. So then we do 4 times negative 15.
Yep.
So 4 times negative 15 is negative 60. Since it is a negative, what does that tell us, either here or here? What does that tell us about the numbers that we're looking for and their signs? It tells us, in this case, because it's a negative, they're different. So one is positive and one is negative. That's what this sign or this sign, they're the same all the time. That's what that tells us. Then we look right here, and what does this sign tell us? The bigger one is positive, right? So when we list our factors, we're going to make the bigger one positive, and they have to add up to be positive 4. So let's list them out. Bigger one's positive. Negative 1 and 60 doesn't add up to 4. Negative 2 and 30 doesn't add up to 4. Negative 3 and 10, no, not 10, 20 doesn't add up to 4. Negative 4 and 15 still doesn't add up to 4. Negative 5 and 12 doesn't add up to 4. Negative 6 and 10, oh, finally, there it is. That adds up to be 4. So then what do we do? See if you remember from before the difference of squares. We rewrite it. 4x squared minus 6x plus 10x minus 15. We group them. What can we take out of the first group? A 2 and an x. And what's left when we divide out the 2 and the x? Right here we'll have 2x, and here we'll have minus 3. We've got to take out the plus sign. Let me pause. I'm probably going too fast. I'll 100 can't breathe. What can we take out of the second group?
5.
A 5. And then what's going to be left?
2x minus 3.
2x minus 3. So what can we take out of both of these?
2x minus 3.
And what's going to be left after that? 2x plus 5. Now, here's where the extra step comes in. This is an equation, right? And like I said, I think we did this the other day. It was already factored for us. We didn't have to factor it ourselves. But if I know that this times this equals 0, remember how that happens? If this is 0, it makes the whole thing 0. Or if this is 0, it makes the whole thing 0. So the 2 times this could be true is, if 2x minus 3 equals 0, that will make this true. Or if 2x plus 5 equals 0, that will make this true. So what do we do to solve this one? And 3. So 2x equals 3. And then what? Divide by 2. So x equals 3 over 2 is one of our answers. Then we come over here. And we do pretty much the same thing. We're going to do what first? Subtract the 5. So 2x equals negative 5. And then divide by 2 again. So x equals negative 5 over 2. So we get 2 answers there. 1 from each factor. Okay, and on these quadratics, there will always be 2 factors. Now remember, sometimes they can be the same. But so then you get the same answer twice, which is fun. Okay, so we get those 2 answers, 3 halves and negative 5 halves. And I think we've got one more. Okay. Oh. I don't have the equals 0 in here. They're supposed to be equal 0 because we're supposed to solve it. That's a typo on my part. Sorry. Oh, one other thing. If it's not equal to 0, cancel out the other side so that it does equal 0. Like subtract from both sides or whatever so that it does equal 0. Does that make sense? So if this said 5x squared plus 29x equals negative 20. We don't want that negative 20 over there, so we would add 20 to cancel that out and add 20 over here also. So make it equal 0. So we can do that this times this equals 0 thing. All right. You tell me what to do and I'll write.
A times C.
A times C, 5 times 20 is 100. Okay, what's important about that 100?
Positive.
It's positive, and so is this 20. So this is positive. That tells us what about our signs?
They're the same.
They're the same. So they are either both positive or both negative. Okay, I'll let people write. Then we look right here. What does that tell us?
Positive.
What's positive?
With a bigger number.
Well, they're
The same.
both positive, right? They're both positive. And then we start writing down our factors of 100. Now, we may be able to do this faster if we just think about it. Can you think of anything that multiplies to be 100 and adds up to be 29? 25 and 4, right? Quarters again. Quarters are useful. So 25 and 4. So we don't have to write them all down if we can think of it. But if you just start going through it, eventually you should find the one that works. So then we use that. We rewrite 5x squared plus 4x plus 25x plus 20. What can we take out of the first group?
X.
Just an x. What's left?
5x.
Plus 4. And what can we take out? We have the plus sign here. A 5. And what's left there? 5x plus 4. You guys are figuring out that pattern, aren't you? Should always be the same. So what are our two factors then?
5x plus 4. X plus 5.
And since we're solving an equation, what do we do with those?
Make it equal 0.
Set each one equal to 0. So if this equals 0, that will give us a solution. Or if this one equals 0, that will give us a solution. Let's do the hard one first. What do we have to do here?
Subtract 4.
And what else? Divide by 5. So x equals negative 4/5 is one of our answers. This one is much easier. We only have one step. What do we do here? X equals negative 5. We subtract the 5. Okay. So that's really, those last two are kind of to set us up for what we're going to be starting on next week. And so we get those two answers, negative 4/5 and negative 5. And again, on your homework, it's going to say supplemental section because it's one I added in. It's not attached to anything in the book that we have been using. So make sure you take a look at those. And I would say try to do some of the practice problems first, probably. I know some of those have videos attached to them and things like that. Remember, 3-1 is due next Monday, and then this one will be due next Monday.